Hello.
Then this is the clicker down is the next.
Do you mean that I can
This
watch
is
at home?
You need to be here. You need to be here. This is important. You're on the zero ground. Okay, guys. Welcome to Geek Sessions Elixir Day. Today is going to be a special boot day for beginners to learn about Elixir and a little bit of the Phoenix framework. Our program, let's talk about sponsorship. We are sponsored by ContentServe.
Hey.
Yay! This venue is ContentServe. They were kind enough to actually loan us the space and some monitors so you can use or extend your computer. I think it's like that.
and coffee and cookies.
Okay, Carl is ringing the door. Please, sorry. And Local.foundation, which is essentially also us, and Penelope. Local.foundation is keen on building communities. We're really focused in building communities and doing this flow between entering the community, building a startup, and being happy.
Realizing your ideas.
Realizing your ideas and your dreams. So, and we essentially work in Elixir on our platform. So we're here to actually share our experience in Elixir.
Oh, screen. Yeah, it's on screen. That's okay. I can go. Yeah. Okay.
So what's the plan for today? We're going to have a full day. I'm sorry for the guys who wanted to be at the beach.
Sure. And there.
No, just show here on the stream. We're streaming. We're going to have a little bit of introduction into what Elixir is, what Erlang is. We're gonna need you to install Elixir and Erlang so you can code it on your machines. We're gonna do a simple modules like Hello World and other exercises. We're going to explain a lot of functionality from Elixir, especially pattern matching, which will allow you to actually avoid a lot of if statements and programming in a little different way than what you're used to when you code in with imperative languages. And then we'll have snacks and drinks like water from the package. And in the afternoon, this may not be like right in the afternoon. Maybe we can start in the morning, depending on how the session works. We're going to introduce you to the Phoenix framework, creating a new project. We'll go with you through live view, which is essentially a functionality from Phoenix frameworks that allow you to refresh pages on the spot and through sockets. We're going to create a chat server that we have an example of a chat server for you to build, and we'll go with you, accompany you till you finish the project. Right? So let's start. For now, we're going to need you to go to this site, elixir-lang.org, install or just scan the QR code. Install Erlang and Elixir.
The reason you need Erlang is that Elixir sits on top of the Erlang VM. It's a bit like the JVM that you run Java on. Sorry?
Wi-Fi.
Wi-Fi. Wi-Fi code is around the corner.
Yeah, I would come, but I don't want to.
I'll do a great service.
The stream is off the slide, so if you walk past the projector, it doesn't matter. Yeah, so the reason you need Erlang is the Erlang provides the VM, the Beam VM that Elixir is sitting on top. And this is why you need to install Erlang and then you install Elixir as a language that sits on top. It's a little bit like Clojure, where Clojure sits on top of the JVM, and then you need the JVM in order to run Clojure. So it's sort of a little bit of a similar concept.
Right. We'll sit here and accompany you through this journey of installing software on your computer that you might not want.
Yeah, anyone got Elixir installed already?
Getting everything from
Sweet. Good.
There are some stickers and bags from our sponsors.
So just checking how's the audio. Yeah. Did anyone check the audio on the stream? Is it good enough?
I am trying.
Yeah, trying.
I think he underneath.
Oh, you can ping Levin and see if he
Yeah.
gets a stream.
Oh, I'll-
Good. Installing Elixir. Anyone need help?
So if anyone needs help installing, either
I suppose it's just gonna be one month through. Yeah, I'm taking my next one.
Yes.
Well,
I think
yeah.
before the
Yeah.
and you.
So you're thinking that.
Someone that doesn't have a whole lot of money gigs and manage to stuff in everything. Sorry about
Yeah, they're getting into IELTS. So don't worry about it. They're just to be good. No, this Oh, yeah, sure.
for the next time.
Go for it. If anyone needs help, let me know. I'll help,
Yeah.
and then you can continue.
Talk to us instead of calling 911 directly. Maybe it's a fake emergency and we can deal with it. No. So while you install Elixir, you were explaining that Elixir sits on top of Erlang.
I did already, kind of. There is another interesting thing. So Erlang, for those ones that don't know, is a language that comes out of the telecom industry and was written in the 90s, 80s, 90s for telephone switches for Ericsson. And the problem that Ericsson tried to solve back then was if you update a telephone switch, put new software onto it, you do not want that switch to drop all calls, reboot, and go like, ta-da, I'm here, I'm accepting calls again. That's not kind of what you expect from a phone call. So they wrote this language that has a robust VM sitting on the bottom, and then you can have several physically switches in one cabinet, and that VM kind of knows of all the physical switches in the cabinet, and you can update one, and that starts to accept. So you do a hot code upgrade onto that one phone switch. That starts to accept new calls. If not all of the calls are dropping right away, you go, okay, well, maybe this update is good. You can roll it out onto the other physically boxes in there. And as soon as all the calls that are on the old version of the software have stopped, the VM kind of drops the old version and you can deploy the next version. However, if you see there's a whole lot of errors, you go like, I probably don't want to roll it out to the other ones. And then you roll it back on the original one and you're back to the normal, to a fully functioning system. Sort of. So that was very limited to Ericsson, and they had absurd uptimes of their actual physical hardware with that model. And then Ericsson went, you know what? Java, way better, because cheaper developers. And the Erlang team went, come again? The whole reason we have this absurd uptime is because we've got this cool piece of software. They managed to open source it, and then the language kind of hibernated along till the web community went and was like, holy shit, this thing is solving all our problems. We have hot code upgrades, we can have absurd amounts of connections in parallel on pretty mediocre hardware. It's like solving so many of the problems that we are seeing in web scale stuff, that this is the solution. And this is when Joe Armstrong wrote his famous book about This is Erlang and explained the basic concepts of the language. And then that gave sort of the first boost for the language. It was, I don't know, 2006, 2007, around that. That was when I first found Erlang and felt like, wow, awesome. I write search engines for domain registrars, which is loads of parallel connections into loads of backends in the backend. So that is exactly solving my problem. Wrote my first search engine in Erlang, and like, yes, awesome. And then sort of the next hype wave came when Jose Valim came along and said like, love Erlang, but I'm a Rails guy, and the syntax is hard. I do not agree with the syntax. And the development experience sucks balls. Like, this is not how I want to write software. And started to come up with Elixir as something that is more readable, has a better developer experience. And the first time I saw Elixir, I don't know, 2000, I don't know, it was half a year old or so, at a Erlang conf. And I was like, oh, it doesn't solve a problem that I have because I'm used to the syntax and the DX I got used to. So, And then a year later, Elixir went so much ahead in terms of development experience and so much ahead in terms of syntax that I thought, okay, I should probably look into it. And then since then, kind of switched. I haven't written Erlang in a while, but I still love the language because it's very terse, but it's also hard to learn. Whereas Elixir is easier to get in, I think. And it sits on the same crazy Beam VM, so you have all the upsides with none of the downsides in my view. Cool. So, everyone installed Elixir?
Good. So as you were saying, the Erlang Elixir works on Erlang and allows you to approach a function paradigm of coding, which is highly scalable because of all the parallel processing that you can do in the example of the registrar domain that you did. And it allows some fault tolerance management with the supervisors that it can actually create. And as you said, it sits on top of the Beam machine, Beam virtual machine, or Beam VM for short. We have some companies here using Elixir. I'm not going to do a deep dive on them, but the most famous one is Discord. As you know, Discord it's a mix of the IRC protocol and Elixir. You also have change.org, which is I think
it's a platform for running what's it called?
petitions.
Yeah, that's it.
Petitions Toyota Connected, which is software on their cars. Heroku is used to be a free site that you could host your websites, but
Heroku was cool before it got acquired. There is one missing that is a Erlang stack, not an Elixir stack. That's WhatsApp. WhatsApp is runs completely on Erlang.
They're kind of famous for that.
Yeah.
They had like what 20 engineers and they sold for like how many billion?
But that's the cool thing about Erlang. You have, so I'll get into that a bit later probably, but yeah, you can run extremely crazy infrastructure with very little development manpower.
and
That's a reason.
yeah. So this table here comes from a very good book that's called Elixir in Action by Sasha Jurek. Did I say this
Sasha.
correct? Sasha?
Yeah.
Sasha Jurek. Which explains you that for most web servers that you run, you probably need a lot of applications like Go, Redis for cache. Persistable data, you'll need some non-structured or non, how do you say it? MongoDB is
Non-volatile data store.
yes, that's right. For cron jobs, you need cron bash scripts or something from your operating system, and Erlang allows you to just ditch that up and you just use Erlang for all these functionalities. That hence what he said, that Erlang allows you to have crazy architecture applications, some very good planning without resorting to other stuff or being dependable on other applications. This is just an example of concurrency in Elixir. It's we're not going to delve deep into this yet because this is beginner friendly, but this is just an example of how you can spawn processes easily to actually deal with them separately.
Just on the spawning processes point, the reason why that's so important is if you try to spawn operating system processes, you're very quickly limited by what your operating system can handle. But the Beam VM, because of its heritage in telecoms, has this property of operating system threads, abstraction, and then in Python you've got green threads. It's a little bit similar in Erlang and Elixir. You can run hundreds of thousands of threads in parallel on very, very standard hardware. And with that, so process is normally where you keep your state, and process is something that you use internally to scale stuff horizontally, because the way the Beam VM is written is that if you've got several VMs that are sitting next to each other and they know of each other, they create a fully connected mesh. And then you as a software developer don't need to think about it anymore, where you put your processes. You just launch your software on, I don't know, 5 servers, connect them, and then they will automatically distribute the stuff around. So the process things are very, very core to how Elixir works and Erlang works. But forget about it, forget about it for now, we'll get back to it.
Yeah. So essentially, these are the principles of Elixir that they allow you to do functional programming. And functional programming means a lot of notions about how to code easily, simple, short, and straight to the point. And for these, you'll need some concepts like immutability, which means that you can easily change the values of variables that you set up. You have pure and high order functions that you'll explain later. Elixir allows for modular programming, for concurrent programming. You can think of it as like several pieces of software that are running in parallel, and it allows you to use pattern matching, which will shape your code in the very unrecognizable way from other codes that you're used to, or other like JavaScript, or no, not real JavaScript. JavaScript is a bad example, but maybe Java, C Sharp, and other object-oriented programming languages.
The other thing that's important here is even though Elixir says it's pure and has higher order functions and so on, it's not Haskell. Haskell goes to the extreme on that. Erlang is a very like real-world language, I would put it that way. Wherever Haskell goes and so like this is the rule, and if you don't do it like this way, you'll die. Then Erlang always and Elixir always has an escape hatch. So if there is a real-world reason why you need to break purity, for example, then there is a library that does that, or a core part that does that, and tells you you will shoot yourself in the foot, but this is how you shoot yourself in the foot if you have to. You can. There is an escape hatch. So it's important. It's a very real-world language. It's not as crazy opinionated as Haskell.
So, coming back to immutability, what I said, once data is created, it cannot be easily changed. Leads to safer codes, to safer environments, especially if you work with a team. Variables once bound cannot be rebound, and if you have Elixir already installed, you can actually use. Let me just go to the. So you can use this example. Maybe we do just show the IEX slides.
You don't have the preview of the slides here.
Okay, I'll just search for it. There you go. So please try the interactive mode of Elixir on your PCs or Macs. And for that, you try to use the command line IEX. That should give you the interactive mode of
Yeah, IEX is a REPL, so you can use it for prototyping, you can use it for playing the code.
Is it that like you can't do x plus, or x equals x plus 1 after you bound it? But if you say x equals 1, then you can say x equals 2 and that works fine.
That is a specialty of Elixir. This does not work in Erlang. If you go ERL instead of IEX and you try that, Erlang goes no. In Elixir, you've got a specific thing. So what happens if you say x equals 2 is that it throws away the first state, it creates a new one, it does not update it. But if you want to have the original one, you can use it with a little, I don't know, it's the roof character.
Oh, the carrot.
Yeah, carrot. With that one, you can actually say, I want to have the original variable. And then it says no. So if you try that, so x plus 1, x is x plus 1, you can't, exactly. But you have x equals 3. Now do the caret x equals 5, and goes no. So this is a special notation that tripped me up initially when I switched from Erlang to Elixir. Because it exactly breaks for me that single assignment contract that you have. But it is a bit easier if you're switching from a language like Ruby to Elixir and go, okay, the single assignment thing doesn't make sense for me. Then
it gives you the kind of it gives you the appearance of immutability, but it's not actually
exactly.
right?
So the immutability is important because you've got a fully distributed system.
So is that
And if you want to update everything in a fully distributed system and you do not have single assignment, it gets really complicated really, really quickly. This is why Erlang and Elixir have single assignment.
But try to do
Yeah.
any carrot x equals.
Okay, cool. I'll quickly continue then. Where are we? So everyone is in IEX, we can play around a bit. Where are we typing modules? Higher order functions. So A function in Elixir is really just a parameter. You can pass it into other functions, you can assign it to variables, and that makes for really interesting code. So this is something that you write all the time. You get enum map, which is a module to iterate over an enum data type. Did we do data types already? Oh, sorry. Other side, functions, immutability. No, it's okay. So we'll get into the data types a little bit later, but this is a list, and we want to iterate over the list. So this is 1, 2, 3. And then you just pass in an anonymous function that takes x, which is the element of the list in this case, and does something with x. So in this case, it assigns x times x, and then fn end is the actual anonymous function. Or you can do the same thing more terse. This is a way of writing things that is very concise, but is very confusing initially. So I do not recommend using that syntax initially. But if you see it, it's nothing else than saying, take the first argument, so n1, fnx, and multiply it with the first argument again, so x times x. This is exactly the same way of writing it. But this is, in my view, a bit terse. And to start out, just keep in mind that exists and what it means, but if you write it, I find the explicit one easier to reason about. But the important takeaway is, like, you see anonymous functions everywhere because they're a really handy tool to pass stuff around, and you can assign functions to variables and then pass those variables around. And that, coming from an object-oriented way of looking at things, is often a bit confusing. But if you come from a JavaScript point of view, that is totally possible again. So kind of combine your language knowledge. But it gets very, very sort of obvious when you start working with it. You don't really think about it anymore. It's just something that's important to understand. Then, as soon as we want to encapsulate functionality into something, you would, in an object-oriented language, you would have an object. In Elixir, you always have a module. A module captures functions that are that, as a group, can provide functionality. So this is basically the container that you use in order to combine a bunch of functions. Normally, a module corresponds to a name, to a file name. So typically, a file name in Elixir is written with underscores and lowercase, and then the according module is camel case, so with characters capitalized. So this is just a convention that Elixir is running on. Every language has their own conventions. Variable names are always lowercase. Then module names are always first capitalized. And the module is very simply defined. You've got a def module, you've got a module name, and then you always have a do end block in Elixir, similar to other, like to many other languages. You've got like a thing that is creating the container, and then in the container you've got your functionality. And in the Elixir case, you've got a do end block, and then the first word defines what it is. Def module or def is a function. You've got a def p, which is a private function. So we'll dive into the finer things of that in a bit later. But the important thing to keep in mind, you always have a do end block, and then before the do part, you've got something that defines what the inner part is, and then you often have something between the definition and the do block that is capturing parameters or whatever. So in this case, we've got a function name, we've got two parameters, and then the do end block, and then something happens in between with the two parameters. In the outer one, we've got a def module, so we define a module, we've got a name, and then we've got a do end block again, and in between there is stuff happening. So just keep that in mind. It's always a do end block, and then there is stuff that is defined in the do end block. Do you want to continue?
Sure.
Okay.
Okay. concept of piping, who here knows? 1, 2, 3, 4.
I can guess at what it does.
Yeah, it's easy. It's just did anyone do a grep function or a grep instruction in Linux and pipe the output for the next instruction? This is basically it's just grabbing the first value that you outputted, pipe it into the next function, and then you can also do these chains of pipes until you get a final result. Just setting up a path of outputs.
Still avoids nesting.
Avoid nesting. Yeah, you can.
Visually, please.
Yeah, and it makes it very clear visually what's happening.
Yeah.
The other thing is, the thing to keep in mind is the first parameter you're passing into a function is always a parameter from the last function. So
The first.
yeah, so this one basically means add 5,7.
Yeah.
And then we take that and put it into output. So here we've got the output of add 7 and 5.
Yeah.
And then this is printing 12. So the first parameter is always the one that comes from the previous function.
Yes.
Ooh.
Yeah, it's pretty cool. And as you said, it avoids nesting, but well, you have many techniques to avoid that.
There is.
And
Sorry, you go.
and with Elixir, you're kind of forced to actually not nest things up because the way functions work is you don't actually need to state returns what you return. You just the final thing that you calculated is returned. And this allows you to actually shape your code a little different and use different techniques like shorter functions to actually understand what's going on. But you'll see it later. You were saying?
Oh yeah, so piping becomes really important as soon as you've got, if you want to break your code down so you don't nest it today, you combine pattern matching on function headers, we'll get into that later. It creates a very important tool to have very clear and concise code that says exactly what it does, and then deal with the complexities of the data that is flowing through in function header matching, in individual functions that are actually implementing all the cases that are happening. So you don't have a lot of case statements or if statements or whatever. You have very clear code and a very clear way of reasoning about the data that's flowing through.
One thing I advise you guys to do is actually when we state these examples, you try them on IEX. So please do that.
The function add is not important in this case.
Sorry?
It says the function add is not important. That's the
That's because you need to do the function to define. We have the function here.
Yeah.
For example, you can copy this function. Try to copy all of this in IEX, and IEX will actually deal it as a module. Test it. You can test it after you actually create the module. You can test it to see if it's working. You probably need to say math.add and then these the parameters.
But I for different things.
Okay.
That would take like 5 minutes.
It works?
Yeah, but you do need to do the math.
Yes.
But in this case, since we're just testing it, we could technically just define the function itself. Right?
Yes, you can.
It will also work.
Yeah, definitely. You don't need a module for it.
We're just wrapping up on a dev module because here we're hardcore.
You didn't.
What is the file name extension for the Elixir file? Source.
EX.
EX.
EX, not EX.
You have it running?
No, I'm not sure, but yeah, I think money,
Mm-hmm.
but I'm like, yes, don't you?
Oh,
Is that what you use?
Yes, that is okay. Yeah, you can definitely use this.
separates ID.
I haven't used that one. I use VI, but that would be not helping. Anyone on NFM, I've got good ideas. Yeah.
Yeah.
I've got a good config for Elixir. We can probably
Yeah.
swap in the lunch break.
It breaks your brain for everything else.
Yeah.
That's right. But I'm not good with playing piano.
It's a good way to speak.
Well, at least all the commands that have passwords I got max.
Oh no. Probably that thing.
I tried Clojure years ago. Clojure was like so heavily reinforcing that.
Yeah.
And I just couldn't try it. It's so powerful, but it feels like you're typing in pixels, which is just weird.
It's better now.
Maybe
Yeah. It's improved the last 2 years.
Probably a few mods like in VI and film changed completely when NFM came along. And NFM just makes it super fruitful.
Yeah.
And yeah, the stuff I have in NFM and Vita, like all complete and whatever with
That's crazy.
awesome stuff like in. Cool, is everyone sort of coming along? Anyone got questions? Anyone stuck anywhere? No, yes, you can just yeah, 5. Five. You can write it in one line. Yes, 5. Yeah, 5, and then add doesn't exist because we don't have the module yet. That would be go back in. So you can go right. No, just take the whole line away. Just define the function add before. Add. No, just then you can just so definitely your map. Now if you try the next one. Oh, there it is.
But the Python one,
That is, let me go map. And another 5.
Also,
No, so you're running.
what kind of you can
Exactly. But if you have a 5,
and
you can, if you start with the 5, and then insert, and then continue, but if you start
like 5,
yeah. Okay.
Not sure how, but use the IEX to do it. Yeah.
Okay. That's unexpected. Okay. Oh, and
Read it in order.
fine. 12. That's okay. Testing gives stuff.
Yeah, it's basically just reading the module.
Bytecode.
Is everyone through with that example? Anyone got stuck?
It's based. He has a
Hello.
pertinent results. He created the module and
Yeah,
he has what is that it's
So this is the function definition. It's hard to read, but it's basically a list of binaries. It's a binary list, but the two
Bytes. These are the
exactly it's byte string.
And this is bytecode.
Yes. Yeah, this is beam bytecode.
Right.
That is hard to read, but
Mm-hmm.
it's now defined, and this is why you can use math and test being built. And nobody would write that into a file, but you can also just do it in a REPL.
So what I was wondering is why I'm amazed about that it's equally applied. This is the first argument that goes into add.
Yeah.
So I wonder when for closure or other functional languages,
Yeah.
I would now expect add set. I would expect this to return a new function with one argument. That very
No, for that you need to redefine it because it says add one is not defined. You need to add two. So this is a different thing. You're in Elixir, the function definition is defined by the function name and what's called the arity. So the amount of parameters you give it. And so add with arity 1 is a different function to add with arity 2. And this seems weird initially, but it is super powerful once you get used to it. Because quite often you've got functions that if you give it a different amount of parameters should behave differently. And you can have default values in there. There's a way of defining a default, but there's also often if you only get one parameter, it's falling here. So where I use a different arity a lot is if I have a function that has two arguments, and if I don't get the second argument, there's a work I have to do in order to find the second argument. So I've got a one argument version that finds me a generic version of the second parameter automatically. And then if I give the second parameter, I've got a specific version of the second parameter. Or where it is also super useful is if the second parameter is a function, an anonymous function that you pass in, you can have a default function that you define in the one parameter version that just calls the two parameter version with the default parameter or the default function. But if you have a specific one, you override it with that. So the whole functionality thing is strange, but it's super powerful once you get used to it, and then you miss it everywhere else.
Is there any syntax or is there any automatic currying in Elixir?
No.
You have to do it.
You have to define it. Everything is explicit. Yeah, there's not a lot of magic in Elixir, which makes it easy to reason about.
Yeah.
There is metaprogramming, which we do not cover today, where you can change the language the same way you could Ruby. In Ruby, you've got a lot of metaprogramming, similar concept. You change the entire language, but it's very discouraged and mainly used for framework authors. We will go into Phoenix, and in Phoenix, there is some stuff that is added by metaprogramming. I'll point that out. It's just extending the language set, basically. But redefining languages is highly discouraged. Very bad pattern.
Okay, we used IEX for the things, but you can also use it Elixir as a scripting option by creating files to call extension IEX. No, not IEX, EXS. So you can also define the functions that you did just now and paste them into let's call it math EXS file, and then the way you run it on the terminal is Elixir and then the file, and you'll have the same output.
EXS.
EXS.
So EXS files are not compiled by default,
Yeah.
and EX files are compiled. So an EXS file will never compile down to bytecode. It will always stay a scripting file. And they are often used for configuration files and for other things that don't need to be compiled, or are used as source for compiled artifacts in a release, for example, stuff like that.
Especially when you use the mix tool that we'll talk later. The other option is okay. The other option we'll talk about it, but for now let's just try to do a script file with the hello world function. The challenge is to create a Elixir script to the hello world program. Here on the project, I tell you to use the Hexdot site to find the IO module. You see how to print values, but you guys already did some of this code, so this should be very simple. So for now, let's just try to do a simple hello world.exs file, simple script, to try and define a module with a function inside that just prints hello world. You did it. You did a more advanced thing just before, so let's just try to make it as a script.
A thing I often do in that case is I've got an IEX window open when I've got my editor open, and then I prototype in the IEX window and then copy over the stuff that works into the editor as soon as it works. The other cool hack that you can use in the IEX window is you can type h to help space and then a function you're interested in. So if you type h space io.puts, it gives you the help for IO puts without you leaving the terminal if you're a terminal person. If you're more a web person, use hex docs. So whatever works best for you.
You don't need spell? Well, I mean, first, this is always great. Yeah, I was going to say.
Elixir, the for the Elixir, there's a short.
So there's this. That one's
Is this the convention? Hello, on the floor. For games which will I heard something about it. Only being on the rights not.
yeah. So EXS is different, but in general, everything comes with the control, which is which is really important for configuration files, for example. Your configuration files are not read at runtime; they're read at compile time, and that often trips people up because the way you normally think about it, like it gets falls in the runtime, but if it's not like environment data that you define as being included at runtime, it is compile time. Upsides and downsides. You can have config that is read at runtime, but the default config is always conforming. And if you've got a release, then it's always going to be the same.
It's this EXS files, the exceptions to that.
Exactly. Exactly. It's not a binary that you flip around. It's just a script that is run on time. Okay.
Where's the live stream camera?
There is one here. It's here.
So we are not even.
No, you're not in a frame, but we can.
No.
no. This is...
I'm just fine like it.
We didn't go to the lengths of having stickers like "Do not take pictures of me" and stuff like that. I've been to conferences where we had stickers for people that like do not take pictures of me. It's super useful if everyone is like respecting it.
Exactly.
Yeah.
Yeah. But for us, it is because it's
Yeah.
quite the nuisance for us to be like, hey, and take a picture, they take it.
Yeah.
So yeah, that's really, really good.
Yeah, we should start that, eh? Yeah, we did a lot of things that we still need to implement here in New Zealand, Australia.
Right?
Yeah.
That's the idea. You just a bracelet system.
Stickers for do not take pictures, and we still don't have a code of conduct. Should have a code of conduct. All of that. Yeah. Cool. How's everyone doing on the scripting challenge? Anyone stuck? Everyone got something?
Yeah, thanks.
IO puts.
Challenge is completed. Congratulations. You now deserve the first sticker. You have all of them, but interactive mode, you already dealing with this. Just hire mixed tool.
Go in front of the microphone.
Okay. So we have a mixed tool here. The mixed tool is similar to, for those who work with JavaScript, NPM, or for those who work with PHP Composer. But here mixed tool is a little bit more broad. It allows you to actually create a project. It allows you to test it, and it allows to actually install dependencies on it. And you can search packages in Xdocs also, right?
Yeah.
Or
Hex in the hex package manager.
Hex package manually. So if you try and do mix new hello world, it creates you a hello world project, and you can actually see the folder structure inside of it. And I think you when you saw Elixir, mix is already part of it. Right?
Yes.
Yeah.
This was some of the comments that I made earlier, where I said that the development experience in Elixir is so much better than in Erlang. One of that is a very generic build tool, and one generic build tool, not a gazillion, not a flavor of the day kind of thing. So we've got one build tool called Mix, and then there is a generic way of extending Mix. So every project can add its own Mix tools to enhance the functionality of Mix. And we'll see that as soon as we use Phoenix. So if you run mix new hello world, and then go into the directory and type in mix help, it will show you all the functions that it currently can run without you having to do anything or install anything additionally. But then every module or every dependency that we install into that project can add mix commands to it. So extend the mix functionality.
All right. Please try to do mix new hello world and see it for yourself. And you'll see the bare bones of your application in Elixir. I think it's also useful to gather all the documentation. You can actually use help or H.
There is a doc command where you can, well, it's a dependency, I think. It's not there by standard. But yeah, there's a few standard things that we normally always pull into projects, so where you can generate documentation, where you can, so testing is automatically there. But as soon as you pull in a database layer, for example, you get a bunch of database commands to create a database, to drop a database, to run migrations. As soon as we run Phoenix, we've got auto generators to generate Phoenix projects, and then within Phoenix projects, we'll get to that, but there's a whole bunch of generators that are created, and a few third-party libraries extend the mixed functionality. The standard one is Hex Package Manager, so that is always there. Also, one package manager to rule them all. So there's a lot of sort of learnings from Ruby, JavaScript, other communities that have gone crazy with like, this is the new thing, use the new thing because it's better than the old thing. Whereas in the Elixir community, we very, very much keen on having one set of tools that works really, really well, and everyone who's got good ideas is very welcome to contribute to the one thing that works very well. And that makes for a very homogeneous community and a very easy way to reason about stuff. Now that you're in your mix thing, run mix format. Mix format is a standard formatter that just strips with mix.
Yep.
And formats your source code in a standard way. And that's another thing that the Elixir community has agreed on. You can override the formatters and you have a specific reason for it, but normally everyone just uses the standard formatter that is shipped with Elixir, and with that, all code looks the same. There's not much discussion. I want to have 2 spaces instead of 4. Doesn't matter. There's a formatter for it.
Yep.
So that's all stuff that the community sort of agreed on. It's not like in Python where it's enforced by the syntax of the language, but there are very strong best practices that are just used by everyone, and it makes it very easy to hop into any code base and sort of find your way around.
Everyone did the project. Any questions? Any problems? Any assistance? Is everything good? Next slide. So here I ask you to do an Elixir project to do a Hello World module, use the mixed build tool. You already did that. There is an introduction to mix that you can actually find on the Hex docs. There's more documentation on it, but we basically said it all, right?
Yeah, there's a test module that's right there. There is a cool thing that's called doc tests. I love that. So doc tests are documentation that you put into a module, and you enable doc tests in your test suite. And by just copy pasting an IEX command into the documentation and the expected outcome, that becomes a test that the test suite is running. So as you write your documentation and write examples in your documentation, you're implicitly creating tests that the test suite can pick up. And that just makes for really good documentation that is actually tested. So I really, really like doc tests. Feature that I haven't seen in many other languages. I don't know if we dive into that today, but that's just something to keep in mind. If you're interested in that, doc tests are amazing.
If we don't dive that today, we'll dive that on another day. There will be more Elixir days.
Yeah.
Or on meatballs.
Yeah.
Next, okay. Now we'll talk about atoms, or the many data structures that we have. In Elixir, atoms are were concepts that were hard for me to understand in the first place. I'm still a bit of a beginner in Elixir, but my first face plant into the wall was atoms, because atoms are a concept for me that wouldn't make sense, but no, they do. For example, in other languages, for us to define keys, we just use strings or numbers, and that's it, right? And atoms here, the concept of an atom is that you have atom hello, and the value of it is hello. But the only difference from a string is that you have a column behind. So why would we want this? Atoms are built differently because they're not here to be strings. They're just here to be used as keys, as very quick, efficient keys for for information. So this is an atom called colonel. There we use them, and this is an explanation that sticks me the most. They're used as stickers. You stick them to data, and then you can use them as this is data that is served for this purpose, or other things like this data is okay, or this data has an error. You can use atoms reliably for that. There's a fixed size of the number of atoms. The most used atoms, I think, is true or false or okay and error. Like it's a pattern in within Elixir developers to use the okay atom and the error atom to actually output information from functions. And CPUs are very friends of atoms because they find atoms very quickly, for example, on a map or on a tuple.
Yeah, the important thing for that is also because pattern matching is so ingrained in the base of Elixir and Lenz. Pattern matching is something that happens always, and for pattern matching, you always need some labels. So like okay or error, they're just labels. In order to match on specific data, you often put them into these tuples. Like, yeah.
So
You had a question? Okay. So these atoms are used everywhere, especially to qualify what a piece of data is, or what a return values is, or if you have data structures that are bigger, they're used to go into the data structures because you can dereference them easily. They're very highly optimized in the BVM, but there's a finite number of atoms. So a trap that early stage developers often fall into is if you create atoms dynamically in your code, you often run out of atoms at some point. In practice, this never really happens. I've never seen a system run out of atoms. However, if you leak atoms somehow that are generated automatically, like a JSON parser that parses arbitrary data, and the data constantly changes, you would create a whole lot of atoms in the system, and that would grow over time, and your system would fall over every 3 weeks, and you wouldn't know why. So that's one of those points where that might actually be an issue. As I said, in practice, we actually have supervisor trees and everything, so it doesn't really matter because the system just comes up again. You just don't know what happened. But that's one of the pitfalls that people can fall into. However, please do not be worried of using atoms. You have plenty of them. And it's just, if you automatically generate data structures that use atoms for some reason, then you may actually run into problems. But as I said, I've never seen it happen in actual production. It's something to keep in the back of your mind. It's a finite number, but the finite number is big enough that you never run into the issue.
But then you must create different atoms.
Exactly, that's the thing.
That is, I mean,
Exactly, yeah.
2 hello atoms are actually the same thing. They don't quite exist.
They are the same thing, and there is also functionality. If you cast a string into atom, for example, you can say cast to existing atom, and then it would fail if that atom doesn't exist yet. So you know, I don't know, as a function name, for example, is nothing than an atom with a fancy thing. You can cast into that, and if that doesn't exist, it raises an error. But yeah, an okay tuple is always okay something. It's always the same okay. It's always the same true. Yeah. Okay. Pointed to the same data in memory.
Okay. Yeah, we have other data structures to have in mind that we can use on our code. For example, tuples, you'll see a lot of these. They're not really very structured. They're just a set of elements inside that are unordered. They are ordered. They are ordered because you need to see you need to check for the first element, the second, and the third. And these are objects that you can actually return. For example, there's not much use to return 1, 2, and 3 like this, but this is a tuple. But for example, in this case, it makes sense because you'll check for the first object to see if it's okay. And if it's okay, you're going to see you're going to treat the message as a successful message. Like it's going to be something that worked well. Another data structure here is linked lists. They're ordered lists, and there's a head and the tail, and the axis is sequential and prepending. You can actually prepend values to it. You'll see it later. And then there's maps. Maps are more advanced data structures that you can use atoms to actually apply with data. And here is an example with atoms. We don't actually use atoms like this. Actually, just in this case here, we're structuring the data of a person, and we can use the atoms like this. This is an atom called name with a column and then the value. And whenever we want to, we'll see it later with pattern matching, when we want to know the value of a given name, how to actually reach it with pattern matching and atoms.
So this is actually a shorthand version of writing it. Elixir has a few shorthand versions of writing the generic data structures, shorter for the ones that are always used. So in a map, you would typically always use an atom as the first part and then something behind it. So this is why there is this version of taking the atom name and a column, and then it expects the rest. The long version of that would actually be column name and then equals larger and then Bob. So this thing is pointing to this thing. But because this is such a common thing, they just went with a name column and then the value.
Yeah, you can try it on EX and try to do the maps on both ways.
If you have a string, for example, a string would be double quotes and then the equal larger and then Bob, and that would make the key of the map the string name and then Bob the value. So with strings you don't have a shorthand because it's a less common way of using maps, but the most common way is to use atoms, and that's why there is a short form for it.
Yeah. Should I go across?
Just a question regarding like name and physical number being an atom. So you can normally define the atoms, for example, on a module level, but in this case, you're saying that they're atoms, but they would only be accessible to reading that map. It's like if you try to look for physical number and use it as an atom, you wouldn't get anything.
Exactly. Nothing is defined globally. Everything is always defined. So that physical number atom is only valid within the context of this map.
Yeah.
There is no actual global variable pointing anywhere.
But it would also be okay if you had like locally defined atom called physical number, and then you would use it there. Or
There is no real thing as a locally defined variable. So
yeah.
you would have physical number maybe as a variable at the module level.
Mhm.
And then you can use physical number as a variable, but then that's not an atom, that's an actual variable. And then what you would use then is like if you want to have that physical number in this map, you would write atom physical number and then physical number without columns, and that would reference the variable that's defined within this context.
Yeah.
Let's see some other syntax here as well. Maybe this is not the right time to fence. With square brackets and then the same notation.
Are we getting to
actually
that?
using maps.
We're getting to that. Just go however you want to. Nope. That one.
All right. So
That's
there
the
are
one.
more
Keyword lists.
There are more data structures that you can use, like keyword lists, in this case is a list that has keywords. You can use it like this with items and values. Still dealt with a list. Or you can use it together with tuples, like on that case. They're ideal for return values, returning values from a function, for example. Imagine that you want to return a list of data from a client or products. You can use structured data like this. Then you can have strings. Strings here are dealt like bytecodes, a list of bytecodes, but you'll see it as strings here in Elixir because it's easier to see it like that. So strings are UTF-8 binaries. They're also char lists. Like if you have a program in C, strings are dealt the same way. You get a chain of characters. And you also have ranges. It's going to be useful later on. You can define ranges from one number to another number, and this is useful when you want to run some function X times, or if you want to define other things like we'll see it later, other uses for it. So from 1 to 100 represents arrays that essentially count from start to end. And next thing is pattern matching. Okay, this is going to be very important. This part is going to be very important because it's going to shape the way you code in Elixir. It allows cleaner code, and you'll see it as you do functions. You can actually do plenty of the same functions, but with parameters following pattern matching. You can do case statements with pattern matching. You can do you can actually initiate variables with pattern matching. And as I said over there, it mirrors all the if statements from all the programming languages. Because people are tired of just using ifs and nesting everything else. Okay, so here's an example that I want you guys to do on IX. This is how we start a variable. We define the variable cake, and you need to define the type of it. Just say it's cake. And we define it to be a tuple with 3 ingredients: frosting, filling, and dough. But now you want to start another variable, and this variable is maybe it's the part that you like from the cake. I'm not sure if you guys are used to working with JavaScript. You have the structuring also. It works kind of the same way, but pattern matching is very advanced kung fu that you can use. You will see later on. But for now, we'll just do this simple part, which is I want to define a variable called part I like, and I'm expecting the structure like this. I know that there's filling, there's dough, and there's the part that is the part that I like. And try to do this. This first, this second. Say that this is equal k, and you'll see that it's the structure in k. Just to find the value that fits this variable, and then output the variable and see what's in there. And the output should be frosting because it's the value that's missing. So, resuming, it's expecting we already know that you're expecting a tuple with 3 elements. And 2 of those elements, the second one is filling and the third one is though. We just want the first one. And by destructuring the tuple like this, we get the variable part that I like. Everyone try it? Let's go next. More pattern matching. Let's say. Okay. Another way to pattern match is with lists. When you want to actually just get the head of a list. And if you do this part here, this instruction here, head pipe tail, this is not the pipe, this is the actually keyboard pipe. So head tail, you get the head, where this is expecting a list. When you do this, the reg, how do you call it? Sorry, in English. How do you call this?
Hashtag?
Hash. No,
Oh.
this is the hash. The
square brackets.
Square brackets. Square brackets. So when we state square brackets, we're already expecting a list here. And we're also expecting with the head, we're telling ourselves that we're expecting an element. And then when you say pipe and tail, we know this is the rest of the list. If the pattern matches, it doesn't give you an error, and the head, if you output the head should be 1. If you output the tail, it should output the rest of the list that remains. Other things that you can do with pattern matching, and I say here in the project, and this is a very cool way to actually define function. Say you have an output of a function and you want to process it. And you can process it the same in this way. You define the same function processed both ways. The only difference is the pattern match that you expect on the arguments. So in this case, it will run if it matches this pattern, and you'll get the result and say I output success result. But if it matches this pattern, the function that runs is this one instead of this one. So it's two functions with the same name. The only difference is the pattern matching. And for example, if I have one external function that gives me error, gives me a tuple with error and reason, a string, let's say a string, and then I run process and that output, the process that will run is this one.
The advantage of like overloading functions as opposed to getting. Even with pattern matching, I would think you could do def process and then if okay results, if error reason.
You can do that, but then you can't use that same section for other things. When you do if statement like that with pattern matching, you're encasing that thing in just one function. I mean, it's the same, but it's nesting a bit. You're just encapsulating more into one process.
Right, I just figured there has to be some advantage of doing it this way because that's the way it's usually done.
Yeah, because we're giving it less responsibilities instead of just doing ifs and then do a
So
function.
it doesn't have to execute all of those ifs to check it, it just matches the first one and only the second.
Yes, and the code becomes cleaner because of it. Unless it's more complicated for you, but for me, this makes sense. In case I met some people that don't like to rewrite the same code, the same function with different parameters. You also see this pattern in C#, for example, or any object-oriented programming. You can define the same function with different parameters or different type of parameters, and it fits and runs the precise function in that case.
So maybe once the code gets to be complex, then the code that actually gets run later, because it's not running all of those extra. It's only executing, for instance, just the success route instead of checking for every other thing.
Yeah, and it's probably this way. It's probably way less lines, and way less lines is already an advantage, in my opinion. Say, writing ifs instead of just putting the condition already here, right? You'll see that it's 1, 2, 3, 4, 5 lines.
But in this case, it's def process to block n, def process to block n, where it could be def process do if, and.
Yeah, yes, yeah, that's an alternative. It's not really wrong. It's just a different way of doing it.
I was just wondering what the advantage is when one versus the other.
You don't need to write ifs. I mean, embarrasses all the if statements, but you're more than welcome to actually write ifs in your function. We're not here to shame it, but see if, for example, the objective here is to make the code cleaner and more and you're seeking patterns to actually read the code better and faster. And what I advise you to do is like create both programs this way, and the if ones with ifs and statements, and reach a conclusion where you actually find comfort and speed when reading programs like this and checking what they do, like in a year or in 6 months. Because that's the objective of cleaner code. Cleaner code is code that you actually write in a clean way, so in 6 months from now you read it and it's clear for you. And if statements makes it clear, then you
I don't
and your
have a
team.
preference, I was just curious.
But if statements are clear, so that's you shouldn't be ashamed of using ifs. That's for sure. I just said it there, just to be cheeky. Okay, more patterns. So we don't use ifs, right? We use case statements. These are like switches, and the way it works is you use pattern matching here, and if it matches, then it executes the result. And if non-pattern matching, non-patterns are matched, you can also use this one. This one matches all every time, but they are executed in order. But it tries to match this pattern first, and tries to match this pattern second, and then this is a catch-all. If none of these work, this will work. You can do the default result. This is similar to the switch statement. Difference is I think it's cleaner, and another thing that you have to have in mind is that if you don't have a catch-all, it can actually output you an error because it actually doesn't find the pattern to match. Sometimes you actually want it to actually output an error. Maybe it's useful for like okay, if it doesn't match, something is wrong, so we need to just output an error and see what's wrong with it.
You could always try to match it. Like this, that might be a use case that you want to, on
Yeah.
purpose, just let it chill, yeah.
Yeah, or you can also output a tuple with error and something went wrong, and then the other function will
Yeah.
deal with it. Okay, so this is an example of a case that you can actually do on IEX or on a script. In this case, we have a tuple with 3 elements, 1, 2, and 3. And we try to match with this one. If it doesn't match, we try to match with this one, and if it doesn't match, we have a catch-all. But let's see what's going to happen. This is important for you guys to see the order of the pattern matching that will be executed. If anyone needs help, please raise your hands. In this case, you can see that both these patterns match in your head, but only one will output, because these are executed in order.
The right-hand side of the arrow, can it only be an expression or also a block?
The right-hand side
To the
can
right
be a
hand
block
the
of
arrow
code, yeah.
Can also be a block. With begin end?
Yes, no, not really begin and can actually do a block of code. Usually. I think there's no begin end, but we'll check it later. And when we do, I think we can, for some reason I don't remember, but you can actually just do lines of code, identity, or just beginning. It just executes this part, and you can actually pipe it around and give you an output. So after you do this case, what I want you guys to do is replace this 3 with a 4. In the expression part, replace 3 with 4, and you'll see a different result. And you can toy with this case. You seem to have a question.
Keeping wide range, keeping it 3 to 4, all the same questions. Well,
Well, because this 3 doesn't match the 4 that will be here.
yeah.
Because it's expecting the first element to be 1.
For that to specific.
Yes.
Yeah.
So if you change the order without changing the read, first. If you just replace the matched with the almost,
those two lines.
Mhm.
It will without changing the read move more.
Yeah.
Next to first.
Because it's executed to the pattern matching environment. All right, let's go to the next slide. Okay, now we do cases with guards. And guards are extra conditions that you can actually add to your cases. Or when you want to explicitly state when something on the pattern matching needs to have a condition. So in this case, we have, again, the tuple 1, 2, 3. And we want to find x here. But the x needs to be positive. And you have this one when x needs to be negative. And these are called guards. Guards will actually give you an extra condition for the pattern matching.
These kind of like guard types in this.
Sorry?
They're like guard types, like TypeScript.
Yeah, I'm not very used to TypeScript, but someone expert in TypeScript here?
Yeah. Sure.
So guards are, for example, is number, is positive number, is positive, I don't know, but there is is binary, is tuple, is so you test for data structures. But then you can also have qualifiers, so it's larger than, is smaller than, is equal to.
Yeah.
These are all used as guards. And guards are heavily optimized in the Beam VM. And you cannot easily define new guards because they have to be fast and they have to be side effect free. And this is why there's a limited amount of guards and there's no easy way to extend it. So there's always a beginner question where you go like, hey, I want to have my own guards. You need to hack the Beam VM.
Yeah.
This is the only way. Also, a lot of discussions on the Elixir mailing list on which additional guards make sense, and they always end in you can actually do it with what we have,
Yeah.
or it's too complex and it's not a case for a guard.
What do you mean new guards? Like new
Is my special guard.
new comparisons, new conditions like
Exactly.
bigger than, smaller than,
Or like the guards that we haven't mentioned here is, for example, is binary or is number. And sometimes you want to have probably a is something specific. And as soon as you reach for that, there is normally a better way of doing it.
you can't call a function in a guard. for
No,
example.
you can't because it's slow. So this is, again, this goes to how, like you've got different levels of optimization within the Beam VM. Guards are heavily optimized, implemented in C code, very low level, very fast. You can rely on them to always work the way you expect them. They have no side effects, they're quick. As soon as you need something more complex, there are other constructs you can use.
Next slide. And then there are many more cases where pattern matching is useful. We'll see it when we go more exercises. They are also used with statements and fin operators. These are also tools that we'll see when we code and are in Hex docs documentation. They're used for control flow, as you saw when you call functions, data extraction, or function dispatch. You weren't here, but there was a pertinent question from Carl before. So there's this process example.
Yeah.
That we use pattern matching to see which function to execute. And the question was, why is this better than using if statements in one single process function?
I figured there must be some advantage over, and this was before he
If
brought
you've
the
got-
very next slide with the case statement, that was exactly what I was thinking of.
If you've got two conditions,
Mhm.
an if statement, an if-else statement works as well. It's just that this is more modular. As soon as you've got more than two, you can just extend it with more header functions that are easy to reason about and easy to work with, because you could have as a closure, as the last one, something that catches everything. It's like there is something completely unexpected. So in an if-else statement, you've got an if, else if, else. So that's 3 already. Or in a case statement, you've got 3 lines. In this one, if you've got actual stuff that should happen on OK, actual stuff that should happen on error, not just giving out a message, and then stuff that happens if you get something that's completely unexpected, then that's an easy way of encapsulating that functionality into something that's reusable again.
Does it also change the amount of code that actually gets run? Since like if each of those were much bigger processes, then if it pattern matched, say, OK, and then only ran OK, then it wouldn't have to actually go through many of the code in error.
That as well, but it's mainly for readability, because this is easy. This is an easy to understand thing that's not nested in some 3rd, 4th, 5th level down in a function somewhere, and you try to go like, where did we start again? So
gotcha.
it's encapsulating functionality into something that's easy to work with. You would
It's a lot
normally,
easier to read the bigger the functions.
exactly, yeah. The other thing is you've got a distinction between def and def-p, and that doesn't apply here yet, but pretend there is a publicly called function up here that has functionality in it that matches on, calls an external API, and the external API returns data that is either OK result or error reason. You've got a relatively small public function where you see we call an API and then we process the output. And then you've got private functions that encapsulate the actual things that are happening. So pretend this is a def-p that is actually doing something with result. There's a def-p that is writing something into an error log and throwing an error message into whatever, and then returns a standard result or whatever. Then your public function is your public API that you're exposing, that you're not changing. That is the contract that you have with the outside world. The implementation that's inside can change as you take, instead of API A, you take API B, and that now returns an OK result or OK-ish result, and now an error result, and I don't know, a false state. And all that changes is your internal implementation, but your public implementation stays the same. And that's also why you often break down stuff that do the actual work into private functions, match them with headers. So if that would not be OK result, but OK result, and then we've got a specific part of the result. If this comes back, we take that. If that comes back, we take that. So you can do arbitrarily deep matching in here that takes out exactly the parameters you want, or exactly out if, say, I don't know what the API could be, you have a payment API, and the payment API returns has worked, we've built the customer, or we tried to build the customer, but the payment is pending, or it could be a subscription things, like we created a subscription in the system, so you've got 3 states already, then, I don't know, the credit card payment is, I don't know, declined, so that's the next one. You need to rebuild a customer. The call succeeded, but the payment declined, and then call failed because the API was down. So these are all things you could map specifically with mapping deep into these data structures, and then have very clear functions that you can call on that without having the spaghetti code where you do all your different cases that may or may not happen in one big case statement, for example.
There's my response and there's his. Okay, text docs. Please bookmark this page here because it's going to be useful for you. If you want to go back and see concepts that you need to be reintroduced. But they're not the only friends here for you. We're also your friends. So don't be afraid to raise your hand and tell us your woes. So Xdocs contains all your documentation. You'll find it useful for conditional statements, loops, and enum functions. Enum functions will be very useful for you. You can question us about anything. So ask away. Okay, now we have a challenge for you guys. I'm explaining here how the factorial function works. Anyone knows what the factorial function does? What's the factorial of a number? So the idea is this is the algorithm of the factorial, and we need to implement it in Elixir.
It's the product of all the
Yeah.
numbers between one.
And okay, so in case the factorial number of 0 is 1, that's a fact. The factorial of number of 1 is also 1, also a fact. If the number we have to calculate factorial is not 0 or 1, we need to multiply it with the next number in line down. But you subtract 1 to the number you want to calculate, and then you do the factorial function on that one.
In a lot of functional languages, factorial is one of the first examples because it uses recursion, and recursion is one of the key concepts. So that's just something you need to get used to, or yeah, something that's good to get used to.
Right. So challenge: code an Elixir module. The module must have functions to calculate the factorial of a given number. And you need to use pattern matching, and if statements are forbidden. Okay? I'll give you not this challenge. This one. I'll give you the algorithm again, so you can read it as you want, as you need. And let's do the factorial module. We're here to help, so raise your hand if you need help.
Plus points if you also write a test.
What
We haven't gone into testing yet. We will in the afternoon.
But it's just following this.
Yes, yes. So one solution to one, the case statement. And the solution in signature with fish, which is so much work. System is like questions. Reason it comes. How you want to match zero, you follow those from that one, and then you want to match everything else. Match one. One, if zero is one, then one, which is exactly zero. Zero, actually, zero. Oh, yeah, that's amazing. Well, yeah. This was the before. Yeah, it will be the X. The one, two. Minus one. Let's see what. So give it a make sure extension is strong. Yeah, you never know. It's technology. All is that's zero. So we could do X y and we fetch it on both. Just to make sure it's not flipped up. And then here x times the following y.
Nice. You know maybe how to actually use concurrency command
No,
for the Elixir function.
I'm really going to check it. The EXF.
Mhm.
In EXF. Yeah.
I can do it in
Yeah, but that's for scripting. The scripting on every week. So
Yes.
yeah,
All the file.
yes, you can. So what you do is you don't write an EXS file, an actual get file, and then you run IEX minus S capital S fix
and that loads all your modules in that directory. And then you can interact with them. Then you can call map, vector, whatever.
Yeah.
That's all the problem.
So for everyone doing the factorial problem, please do factorial of -1. If it crashes, it's your fault. Use guards.
Just a little bit through, see what it does for me. I don't know. See.
You want to stream so
Sorry?
you want to stream what you're about to code?
I can.
There you go. Yeah, we can. I have it on my drive. How many right now? Oh, right now, yeah. Let's just change it there on screen. Oh, wait, let's. Think up what's nothing means.
Ah, it is.
No. You had a position from would be the when you call a function with the brackets option. But maybe they are not. That which I call the journal function like this. You always have brackets in the check.
If you always have brackets.
Yes, okay. It was something else.
Oh,
Yeah.
okay. Computer bits and things as well. Okay, so the syntax was right. It was.
It was in the call of the top level call of this factorial function.
Yeah.
I omitted the bracket.
Ah.
Like in Ruby, but
Yeah. Ah, yeah, no.
and apparently, I don't know much. Let me tricks.
Yeah, so
Yeah.
that's a starting point. Anyway. Okay, if you figured it out, I don't need to.
Yeah.
Everything is pretty laggy on this machine because of the live stream. It's crazy.
Oh, yes.
Yes, S in your
Yes, that's and that just needs to know. Yeah. No. It's like two and a half minutes.
I'm trying to be what you can use those error and but then it's useful for when you call this function all the times. Right? Like if you just do this function, then you the IO puts you into like like if it's this error tuple, then why it's the people. Yeah. Or anything else, like, you can show. Like I'm doing this. Yeah. Like kind of that. I did it with X, S6, and dots and shoes. So I'm gonna this is going to be it would have been we lost big amount basically just the information module that that's so are you on the same links? So this grading styles. Normally we have let's see. Economics. Yes. Yeah, so let's check the buffering which is so I'm figuring this thing. We have a lot of by balance. Yeah, that's about that. Yeah.
Yeah, does it start to make sense a little bit?
Yeah.
Yeah.
I can do parts here in efficiency.
Not in function signature, but after the function signature. So we'll be looking at
Yes.
after the brackets. Where?
There you go.
Yeah, sure. Exactly.
See. Does it have tailbone? A tailbone optimization.
Yes. It does.
Yeah.
It does.
Nice.
Yeah.
Something's done. So, I'm in the folder that has both of these.
Yes, you're not in the lib directory. It's easy to look in the lib directory, otherwise it can make a file. No, you look at the CSS. Does it? Damage? Then it just applies it. You can configure it. But you need to look in the lib directory, otherwise this is valid. You want the file, then everything.
If you're saying deleting is
It worked before when I just tried to run it from the command line.
Yeah.
But it's
the next thing.
No, it's a generated by the order. And that means, yeah, just hit tab and see if all completes.
Cool. Everyone roughly where they want to be?
But I don't want to get it in. I don't want to input it without having to input it. I want to do.
When
You have to define any mini function.
Like that.
That's because that's not super.
Right, but what I'm saying is if I wanted to be able to input it like this, how would I actually write it down?
You need to input it on. And that's very advanced thing. Now, let's say
Like, just ignore the exclamation points and don't.
I got that. Normally, you say yeah, are either macros or they mean something like they actually mean something when it comes to function. They are functioning exclamation marks, question marks, and for the function to get question marks, it's implied that it either returns true or false, and the exclamation marks implies it's a model. But that's something that might help him out with that person. The string.
I was gonna say this integer. Just in case, let's say that.
So you can do a second function when it's string, just one thing, but it's integer. It leaves the switch forward in the text off and see if all tries work in that case. So, everyone good? Everyone ready for the next simple challenge?
There are a few things that I just noticed that I wanted to quickly drill into.
Okay.
In a header definition, if you're matching for a variable, but you're not actually interested in the variable, so every now and then, because a variable has an arity, you need to have that parameter in there, otherwise you're defining a different function. If you precede a variable with an underscore, it's ignored. So Elixir knows there is a variable, but it doesn't care what it is. If you do not do that, then the compiler throws a warning and says, hey, there's an undefined variable, there's a variable you're not using. The development experience in Elixir is very, very geared towards holding you by the hand and go like, hey, there's some stuff you maybe have forgotten, there's some stuff you may have missed. But there's also always a way to say, yeah, this is intentional. So the compiler really tries to be helpful. Sometimes it's too helpful in order to make it shut up, precede something with an underscore, and then it knows, okay, you know what you're doing. That was the one thing. The other thing is, with a factorial, for example, you can have guards in the function definition. And how that works is you capture your arguments in the brackets, and then after the brackets, but before the do, you've got your guard. So, for example, when x is larger than 1, for example. Do you have that in there? Ah, sorry. Yeah. Yeah, you have your guards. So that is exactly the construct you would use in order to safeguard against a -1. And then how you could structure it is you've got a specific case for 0, you've got a specific function for 1, you've got a specific function for positive integers, and then you've got a catch-all that just says is not defined for, and then whatever the negative number is you got. And that way you can do everything in function header matching and don't need to ever have a case statement or if statement or whatever.
Do we have time? Or should we? So if you have, my plan was, if you have time, we do the Fizzbuzz challenge. The Fizzbuzz challenge is this one. If we don't have time, so Fizzbuzz, the objective is simple. You have a number n, and you need to loop from 0 to n. In for each number you loop, you need to check if it's a multiple of 3, multiple of 5, or both. If it's a multiple of 3, you print fizz. If it's a multiple of 5, you print buzz. If it's a multiple of both 3 and 5, you print fizzbuzz. If nothing else, you just print the number. Okay, this is the last challenge I have for the morning part, and then we'll go to Phoenix. So depending on the time we have, we'll try to do this. And
Yes.
the objective is to actually see ranges in action and use the enum each. There's a thing missing in this slide is that there's a function that you need to use to see if a number is a multiple of something. Normally, when you calculate it, you check for the remainder when you divide it by 2. If the remainder is 0, then it's multiple. And the function is the rem from the module math.
Rem, REM. We can also just start with Phoenix. So the afternoon is all about web stuff and interactive shit and so on. So no more maths.
And don't worry, module doesn't matter. Thanks. Not much of that has a function called rem, which is the remainder calculates the remember given the division. So basically, when you want to see if something is a multiple of 3, you try to divide that number by 3 and see if the remainder is. You don't even need to do it. Just call the run with the parameters n and 3, and the output is 0, and it's floating. So when you need help,
Need help here? No, I think so. Reach data. Yeah.
I'm gonna give you the solution in a bit. So we can release it in the wild. Chemicals over there. So anyone devise the solution? Is it complicated?
I don't sort of, I think that it's got the nice solution to case. Actually, measuring with basics, they're not else not necessarily. Okay, but I think there's a schedule related. Oh, I don't know after that they're gonna answer. Yes, so let's put a different one. It's you. Let's try to do a case of the house if it works though. And inside the double, you probably remain for 5 inch. Yes, and then let's pattern match the results. That's what I'm doing now. So maybe it's case reminder. Yes, remainder is 3 remainder 5. That's still gonna match pattern match that too. But I'm not sure if this is if I can. So my this is correct. And then okay, either than anyway. Yeah, they are different cases. This is the what's this? This is this. And the other one is those.
Yes. And you don't need X for anything. So you can just do underscore X or just underscore.
Here. I'm actually
I like the first one. Really. It's almost a number, right? It's I mean, it's not. No, it's not wrong. It's not wrong. It's this was so 0 is equal to 4, 5, and 3. So that's correct. It's good, right? You know, but yeah, that's definitely a solution. It's working. In my opinion, it's very happy. Really? Yeah. Yeah, pretty well. Simple codes and that's all. Thanks. Okay. I'm just gonna illegally access this folder. There we go.
Basically, there's that bug with whatever number. It calls this called FT, so they're all famous, whatever it is. Current number, and it'll be in my stance. And then, it'll calculate the name. That's zero, so that's anything on the same phone.
Yeah, but then the admin will finish like you like on the
It's not with that, with that.
so let's get started. Well, I look at something like I have no idea why that's true because if you don't write it, it's fine. I don't think it's like it's just time go just put in.
Yeah.
Oh, I was thinking gender 3, I didn't think about. Yeah. Okay, that'll change everything then.
Yeah.
Oh, okay, yeah, my logic.
Yeah. Yeah, let's go for that. Anyone still stuck?
Just show here the solution. Can you show it in the what's that screen? It's gonna be 5. How many solutions? But the shorter in here, we'll give you in a minute.
Ah, no. Mushed it on the wrong one, sorry. This is screen. This is the one. Where's my mouse trapped? Here we go. No.
Maybe in your code editor, just paste it there.
Where did you put it? It's in here somewhere.
Yeah, it's in the middle. That's why you have a little bit of scope.
You can also look at the positions if you need to process.
The problem is the windows just too tight.
Yeah. 4. So here we go.
Okay, this is the example of a solution where you simply just devise the module, you create the model feedback, you have a guard, and you run it only when n is more than 0. And then you do this for loop using a range 0 to 1. And then you create this tuple on the case. And I see some solutions with this case also. And you do both of the calculations over there on the tuple. And if the result is 0, 0, it prints this one. It means it's multiplied by 3 and by 5. If it's only 0 on one side, well, in this case in English, it's multiple of 3, which is this. If it's 0 on the other side, it prints plus. Otherwise, it's just prints the number. That's what you need to do. And you can run it.
Oh, it's like way better solution, but I know.
No worries, this is how you learn. Right. That's it.
Cool. Shall we break for lunch?
Yeah.
Find some food somewhere. And then
Yeah, hunt some deers a little bit. Eat some probably.
cool.
I'm sure you can stop, like, pause the stream,
I can on my end.
and then I don't know what happens to YouTube, but I guess we can just figure it out.
Maybe you'll end up with 2 streams, 2 videos. So one with the Elixir, one and one.
Yeah.
Just keep it open.
Well, it's just because if it keeps open, we'll have like an hour and a half.